Hello everybody. This is your notes video on segments in circles. Okay, so this video is just going to be about some properties, about different types of segments that show up in circles. We talked about and defined a lot of them in the previous video. So in this one, I'm going to go into more detail about the specific properties that show up with these types of segments, specifically with tangents, secants, and chords. Right? So let's go ahead and jump into it here. Just as a quick little refresher for you, okay, we have the difference between a radius, a diameter, and a chord. So just as a reminder for you, okay, a radius, which I'm going to draw in pink on my slide here, goes from the center, okay, which goes from the center of a circle out to the circumference of the circle. Okay. There is the diameter, which I'm drawing in black on my notes here, is essentially cuts a circle in half. Right? It's a segment that connects the points on a circle, 2 points on a circle, and then goes through the center. Okay, and just one quick reminder for you that if you take the radius and you multiply it by 2, you will get the length of the diameter. Okay, and then lastly, we have a chord, which I am marking in green. Okay, is just any segment that connects 2 endpoints on a circle. Okay, it does not necessarily have to go through the middle, right? It just has to connect 2 endpoints that are on the circumference of the circle. Okay, so key things to know and to keep in mind, it's important that when you look at an image that you're able to differentiate between these, as well as tangents and secants, which we're going to see again in a moment, because all of them have different properties, right? So if you're dealing with a chord, right, you have to know it's a chord, right, because it has much different properties than a radius, right, or a tangent or a secant. Okay, so we're going to talk about tangents and secants. Those come next. Okay, so tangents and secants are the lines that intersect the circle and keep going, right? So chords will always be line segments because they'll always be confined or trapped inside of a circle. Okay, secants and tangents more often than not will be lines that can go on in either direction, and will have arrows on either end, like they do, like here, right? And there's obviously not arrows on some of these other ones, right? But that's just because Miss E pulled some of these from the internet, and they're not all perfect images. So there is only one property for secants. Okay, just as a reminder for you, okay, a secant is most typically a line, but can sometimes be a line segment or array that intersects a circle in 2 points. Okay. Like I said, there's only one like majorly important secant property, and this is what it is. Okay, that when you have 2 secants that intersect outside of a circle, which is what you're seeing in this image here. So I have 2 secants, the one in red and the one in purple. They intersect here at point P outside of the circle. Okay, then the rule is that the product of one secant segment and its external segment is equal to the product of the other secant segment and its external segment. Okay, so this makes more sense really when you can draw it and kind of label it and see what's going on. So that's what I'm doing in the bottom here. And I'm going to slightly change my colors here so that I can write in the same colors that I'm drawing in. So I'm going to draw on this one that says secant property. I'm going to draw 2 secants. Whoop. Here, and then we'll draw another. Actually, hold on. I really should have that secant extend outside of the circle, just so it's a little bit more easily recognizable. Okay, so here we go. I have two secants and they're intersecting outside of the circle. I'm essentially duplicating what you see on the left side of the screen. Okay, so they're going to intersect here at point P, right? And then each secant intersects the circle at 2 points. So the purple one is intersecting at points A and B, and then the blue one is intersecting at points C and D. Okay, so essentially, this is the rule. Okay, if you multiply the whole secant times only its external segment, okay, so if I multiply the external segment in the purple with the entire purple segment, okay, so if I do PA times PB, okay, that has to be equal to the same thing with the other secant. So if I multiply together the external part of the secant with the entire secant, okay, those two things will be equal. So this is PC, the external segment, times the whole thing, PD. Okay, so it's essentially part times whole equals part times whole, right? That's essentially what's going on here, where you have part times whole equals part times whole, right? Part whole, okay? All right, so that is your secant property. Okay, so just as a quick example for you, right? If I knew that PA was 2 and PB was, I don't know, PB was 6, sure. And then let's say I knew that PC was 3, but I didn't know how long PD was, right? I have 2 times 6 is 12 equals 3x. So that means that x, the entire length of that blue, secant would have to be 4. Okay. So with a lot of these, and what you're going to see throughout this unit, is that a lot of these have certain formulas and rules that if you kind of memorize the formulas and rules and you plug things in the right places, then you'll be able to solve basically any problem, right? But the difficult part and the geometry part is knowing what those formulas are and understanding the relationships and then being able to identify the parts correctly and plug them in the right spots, okay? So that is your secant property, okay? Tangents are extra special, and they have 2 properties that we need to remember. So just as a refresh for you, a tangent is a line that intersects a circle in exactly 1 point, okay? So first property of tangents is that tangents are perpendicular to exactly 1 radius. Okay, and I'll show you what I mean. Okay, so if I draw a tangent, say here, like this, okay, and here it goes, it intersects in exactly 1 point right there. All right, I can draw lots of radii. I can draw an infinite number of radii in a circle, right? You can draw them from the center to any point on the edge of the circle, but there's only one, oops, I meant to change that color. Okay, there is only one radius going from the center to that point where the tangent hits the circle. Okay, there's only one radius that will intersect that tangent at a right angle. Okay, so remember that's what perpendicular means. Okay, what you're gonna see in a lot of these types of problems is you'll see, not very well drawn by me, but something like this where they're gonna try to make a right triangle out of a radius and a tangent. Okay, so ding, 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 right? The thought that goes off in my head is, well, then we're probably going to have to use Pythagorean theorem at some point to maybe find some missing values here. Okay. All right. So that's the first tangent property. Second tangent property is a little bit simpler. Okay. It's just that two tangent segments to a circle that intersect at a point outside the circle are congruent. Okay. So again, I'm going to draw two tangents. Okay. Going down here, right? There's my blue tangent on the left, and then here's my, there's a purple tangent on the right, okay, of my drawing. Okay, so they're gonna intersect. Let's say this is X, this is Y, and this is Z. Okay, so all this says here is that XZ, okay, so that distance from Z to X has to be equal to YZ. Okay. All right. So that is it for your tangent properties and your secant properties. So just a reminder, okay, for the secant properties, you have the part times whole, right? So the external part times the whole thing is equal for both secants. Okay, tangent property number 1, you have a radius and a tangent. They'll intersect and form a right angle. And then tangent property number 2, you have these two segments that will be equal to each other. All right. Okay, so last little bit of this video, we're going to talk about chord theorems. Okay, if we thought secants and tangents were special, chords are extra special because they get not 1, not 2, but 3 special properties. Okay, so here they are. First property, when you have a diameter and a chord, when those two things are perpendicular, the diameter bisects the chord. Okay, so here's what I mean by that. Okay, so here under property 1, if I have a diameter that I'm drawing straight through the middle of the circle, okay, and then if I draw a chord that is perpendicular, I'm doing my very best to draw this so that they're perpendicular. Okay, if I draw a chord that is perpendicular to that diameter, okay, so I'm gonna, whoops, just kidding, forgot to switch my tool. Okay, so if those two are perpendicular, then that means this chord is cut in half. Okay, so now this is another place where, because you have some perpendicular parts and some right angles, that questions will like to, oh, look, draw another right triangle in there, right? So all of those tools that we used for right triangles in the previous unit may show up every once in a while here because you have these perpendicular things going on inside of your circle. Okay, so that's property number 1. Property number 2 states that two congruent chords, okay, so meaning chords that are the same length, are equidistant from the center of a circle. Okay, so if I draw under property number 2, two chords that are equal in length, I'm doing my very best to make them equal in length here. So something like that. Okay, so what that means is what this property says is that the distance from the center to this blue chord has to be equal to the distance from the center to this purple chord. okay, that those distances right there are equal, okay? And this goes both ways, right? So I'm putting my little congruence markers here on my chords. So if you know that those distances in the middle are equal, then you know that those chords are equal, even if it's not marked, all right? Okay, then my very last property, and this is the one that gets used the most. It's the most common property. It's also the property that's showing up in your homework or practice assignment for this section, I believe, is the multiplication property for chords. Okay, so when two chords intersect, the product of the two segments of one chord equal the product of the two segments of the other chord. Okay, so again, these usually make a lot more sense when you can draw them out. Okay, so here I'm going to say, let's say I have this chord right here in purple and then this chord in blue. Okay, and I have certain lengths, right? So I'm going to call this right here A. I'm going to call this part of the purple one B. Actually, I really should be writing these in a different color. One second, let's switch my color here. Okay, so this part here on the left for purple, I'm calling A. This part on the right for purple, I'm calling B. And then for the blue chord, I'm calling this part kind of in the bottom left C, and this part in the top right D. Okay, so what this rule says is that if you multiply A and B together, so multiply the parts, it has to be equal to the product of the same thing with the other chord. Okay, so essentially what you're doing here is multiplying the parts. Okay, so essentially what this is saying is the multiplied parts are equal. All right, so that is it for this video. Okay, in the next one, I have lots of practice problems for you that I'm going to go over for you. A lot of them deal with the Pythagorean theorem, so just keep that in mind, right? Like I said, if nothing else from the right triangle unit shows up in this unit with circles, expect to see the Pythagorean theorem a couple of times. All right, so I will see you all in the next video. Bye, everybody.